So in this video, let's talk about drawing the Lewis structure for, well, that didn't go as planned. But let's talk about drawing the Lewis structure for SO2, sulfur dioxide. How do you draw the Lewis structure for sulfur dioxide? You're giving this on the exam and you're freaking out. Oh my goodness, my teacher thinks I'm dumb. What the hell is going on? Well, take a deep breath. We're gonna go through it so you can't get it wrong in your exam. So the first thing you want to do is go to the periodic table. And in the periodic table, I do not have it in front of me, but in the periodic table, you should see a column over to the right that has oxygen first and then sulfur beneath it, and then a couple of other atoms just below that. Everything in this column has 6 valence electrons. Going over to the right side, we reach the halogens, and everything in that column has 7 valence electrons. And then lastly, we reach our noble gases. And everything in that column has 8 valence electrons. So knowing that, I'm just gonna write the amount of atoms I have, well, the different atoms I have, and how much each I have. So I have 2 oxygens. So based on the periodic table, sulfur has 6 valence electrons, so I should get 6 valence electrons from sulfur, and I also should get 6 valence electrons from oxygen. So let's count up the total number of electrons that we should have here. So this is 2 times 6, which is, I'm sorry, not 2 times 6. We have 1 sulfur atom, which has 6 valence electrons, so that's 6. We have 2 oxygen atoms, but we have 6 valence electrons apiece, so that is 12 plus the 6, so we should have 18 electrons total. So usually in a molecular formula, and I say this usually, not all the time, the atom furthest to the left in the molecular formula becomes a central atom. So at this point, I could just form 2 oxygens around the sulfur, and I know that I have to at least have a single bond. That's just the nature, right? It's just right. I always tell students that Lewis structures, when you first getting to draw them, they're pretty much like experiments. But I usually typically start with a single bond. So a single bond consists of 2 electrons. So this would be 2. So this would be 2, 4. So right now I've used 4 out of the 18 electrons that I have to place. So I still need 4 more. I still need, right? I still need 14 more to place. So what if I form a double bond, right? And sometimes you're not quite sure if the structure is going to work out. You try different experiments. But my reasoning for forming a double bond between the sulfur and the oxygen on both sides is because I know that oxygen is one of those molecules that in all likely has to satisfy the octet, right? So at this point I have 2, 4. At this point I have 2, 4. So I've used 8 electrons total out of the 18 that I have to use. So I still have 10 more to place. So if I go ahead and get oxygen octet to be completely full, then this would be 2, 4, 6, 8. So I know this oxygen is satisfied. If I do this on the other side, then this becomes 2, 4, 6, 8. So both oxygens are satisfied. So let's count how many electrons we've used thus far, and let's see where we're being deficient, if we are indeed. So this is 2, 4, 6, 8, 10, 12, 14, 16. So that means we're missing 2 electrons. And the only place, since both oxygens octet are full, the only place that we could put these 2 electrons would be on the central atom. And ladies and gentlemen, this would be the Lewis structure for SO2.